Oh, it's cold. All right, folks, welcome to session 4 of Python. So, the time has come to make some decisions in our program. Decisions. Decisions are important because decisions make up some of the they make up some of the fundamental basics of most programs. For example, a simple decision is this button clicked? If yes, do this. If no, do this. And then apparently, if this button is clicked, dance. Decisions are everywhere. And if you remember in some of the original outcomes, you had to make programs which branched. And branching is basically making those decisions. And then stacks of decisions within them as well. So, what does this look like in programming? These are what we call if, else, and elif statements. And that is what you are going to be learning about today. You're also going to be learning about nested if statements, which is if statements inside of if statements. Wow, my head is moving crazy today. But let's get straight down to it by looking at, first of all, the planning that's involved in all of this. So, here, hopefully on the screen you see in front of you, is a very basic flowchart. Now, the design of the flowchart is that a diamond is a decision. So the diamond will represent your if-else statement. In this particular case, it's asking the question, is the door open? If yes, you go through it. If no, you have to open it. So that's a very basic decision. How do we put this into code? Well, let's bring up REPL and let's start it in. The first thing that we're going to need to do before we can actually do any kind of if statement is we need to compare it to something. Now, the comparisons you will have on the website and on Classroom to look at as well. There are the standard comparisons: equals to, not equals to, greater than or equals to, less than or equals to. Those are the basic 6 comparisons that you will be using. So in an if statement, you're always getting some data and comparing it to other data. So let's get some data first of all. Let's create a variable called door. And let's set door equal to open. Okay, simple as that. Now, to do an if statement, we're going to be learning a couple of things here today. The first thing about an if statement is that we call it a control flow. And this is where I'll start to introduce you to what are called blocks of code. So a block of code is basically a section of code that exists within a control flow. Excuse me, cough. Cut that. No, I probably won't be cutting this. And to represent blocks of code in Python, rather than using the squiggly brackets, which some of you may be familiar with in C, it just uses indents, white space. So we're going to be using the tab key a lot. But the first thing I have to do is set up my if statement. So I'm going to ask the question, if, then, open my brackets, if door equals. Now this is important. So you probably saw in the comparisons that equals to was actually the equals symbol. It was 2 equal symbols because this is once again the difference between assignment and comparison. You can see on my variable of door, I have assigned it the value of open. But in my if statement, I am comparing door to something. And in this particular case, I'm going to compare it to open. And if door is equal to open, then we're going to be able to do stuff. Now, that's where the difference between assignment and comparison is. It's very important that you know that. Now, this is one of those times where we actually have to use a new symbol in our if statement, which is a colon. Okay? The colon indicates that a block of code is about to start and that our control flow is about to start. Now, this doesn't like me because I haven't got anything else there, but we're going to ignore that. Now, I've hit enter and that has automatically indented my code thanks to the IDE. If it didn't, just press the tab key and you'll be fine. But now that we're inside the if statement, what are we going to do? If the door is open, well, we had our instruction there, so we'll go through, and to represent that, we'll do a print. Go through. Now, I'm going to leave my if statement there. So I could do other stuff in here. I could print Yay! And all of this will only happen if the door is open. I can leave my if statement by going back, so pressing backspace until I'm back to the beginning of the line, which indicates that I'm out of that control block. And then I have to print, or I have to do what happens if the door isn't open, which in this case is an else. Now an else doesn't have arguments. You go straight into the colon for else, so else colon. It doesn't have any arguments because its arguments are whatever the if is not. So if the door isn't open, that is what the else is. So we put the else in and we can print open it. Okay, so let's run that program and see what happens. So we go through, yay, because the door is open. If I come up here and set the door to closed, then I can run the code and we get open instead because the door is closed. Here's the thing though. Realistically, I could set the door to equal to Boris, our good old friend Boris, and it will still run open it because the door is not equal to open. It is literally looking at a particular string and saying, is this string equal to this string? You could also do this with numbers. The door could be equal to 0. And if the door is equal to 1, the integers go through. In this particular case, it's not going to open it because the door is equal to 0. I can make the door now equal to 1 and we'll go through. You can only ever compare the same kind of data types though, because if you compare the integer 1 to the string 1, it won't work. They will not be the same. Let me just see if I'm, not lying there. And yep, no, they don't equal the same thing. So you must compare the same sort of data types. Okay. But this is where you can create an interactive code. So rather than door equaling to 1, door could equal to input, is the door open? Ask the user a question. If door equals yes, then go through. So let's ask the user a question. Is the door open? Yes. We go through. Yay. Is the door open? Nope. Open it. Run it again. And this is the trick though. Is the door open? Yes with a capital Y. Open it. Because they are not exactly the same. Our yes in our if statement has a lowercase y. So you will need to make sure that you leave specific instructions or do what we're going to be learning in the next session, which is kind of controlling and manipulating our strings at the point of the user input happening. So that is a simple decision. But what's a branching decision, you ask? Well, let's have a look at this. Now, this flowchart is for a branching decision because we have a decision inside of a decision. If we look at the flowchart, we ask ourselves a question at the beginning. Is the door open? If it's not, we open it. If the door is open, however, we're going to ask ourselves another question. Is it on fire? If the door is on fire and open, we're going to run away. If the door is open and not on fire, we're going to go through it. So that's the plan for our branching decision. How do we reflect that in code? Let's have a look. Let's leave this little guy over here. If we can, probably can't. You can just remember it and go back to it. So we're asking, first of all, the question if the door is open. So if it is open, so we'll leave our input there for the user. If the door is open, rather than going through, we are going to create another question. So we're going to go if fire equals yes, colon, and then from there we'll go print run away. So this is a branching statement. So we've gone if the door equals yes, then we're going to immediately ask the question if fire also equals yes, and if it does, run away. If it doesn't, so if it's not on fire, then we can just print go through. Okay, so if you can see here now, this has got a bit of an issue because we haven't defined fire yet. So we can actually come up here to the top of our if statement and go fire equals input. Is it on fire? Now that we've got that, the if statement is happy. But here we go. So as you can see, all of this here, all of this section of code here, all exists inside this if statement. So fire equals input, is it on fire? The if statement and the else, they're all inside this if, which is our yes on our flowchart, which you can see here. So all of this stuff exists inside of this one little yes here. Is it on fire? Run away and go through it. Because our main statement, so our first statement with a no, which is our else, so the door isn't open, exists inside this block. Whereas everything exists inside of the else here and in the main statement. Okay, so let's run the program and see how it works. You know what? I think I'm actually just going to leave the lights off because it clearly just... Or they're going to turn back on. Anyway, let's run the program and see what happens. So, is the door open? Well, yes. Is it on fire? Yes. Run away. Woohoo! All right, awesome. Don't play with fire. Just don't. Unless you're in a science lab and supervised. Let's run the program again and see what happens if the door is open. Yes. And is it on fire? No, it is not. So we can go straight through. Woot. And finally, is the door open? No. So we're going to open it. So that is a very basic program with branching decisions. One more thing. So note here how in our flow chart we've only got yes or no for our decisions. You can have multiple decisions. So it doesn't have to be just a yes or no sort of option. You can have 3, 4, or as many as you want. You can do this using the elif feature of an if statement. So there's if, elif, and else. So how about I just show you what that looks like? So let's say on our plan, we, instead of having the branching decisions, we have is the door open, but it can be 3 different kinds of open. So if the door equals yes, then we'll just go print go through. Okay, now we've got an elif. So elif is another option. If door equals no door, there is no door, then we can print build one. And else we will just write for ourselves print open it as normal. And the program has reminded me I forgot my colon at the end of elif. Gotta love those lights. I forgot my colon at the end of elif, so I've had to go back there and put it in because the elif statement is pretty much exactly the same as the if. It is elif, give it a set of parameters to work in, so compare this to this, and have an option if that ends up being true. So let's run it and see what happens. First of all, is the door open? Yes. So we get to go through. Second question, is the door open? There is no door. We get to build one. And then third option, is the door open? Nope. Open it. So anything else will trigger open it. So that is a really weird way to say that. All those were decisions. So you've got basic if statements, you've got branching or like nested if statements, so if statements within if statements, within if statements, within if statements. And then you've also got elifs, which you can use as well. So all of those together you can use to solve this lesson's challenge. Enjoy.